Good afternoon, students. We will first tell you what is thermodynamics. We just recall you certain part of thermodynamics because we already taught in this class just 2 or 3 classes. I first tell you that thermodynamics is the branch of science which deals with the interaction between energy and material system. That means suppose we consider a beaker. Suppose this beaker contains 2 or 3 pieces of ice. These are ice. After some time, this ice is converted into liquid. That means this beaker absorbs energy from the surrounding. As a result, the temperature, which is at 0 degree centigrade, is converted into 10 degree centigrade. That means temperature increases. It absorbs energy from the surrounding and ice is converted into water. So that there is an interaction between the system energy and the between the energy and material system. Similarly, if you put a contain a beaker, you keep it at hot hot water, suppose at 60 degree centigrade. After some time, you see that the energy is exchanged from the system to the surrounding and the temperature will comes down to the room temperature. So this is called thermodynamics, how the energy is exchanged between the between the system and the surrounding. So this is called as the thermodynamics. So thermodynamics is the branch of science which deals with the interaction between energy and material system. So there are two types of thermodynamics. Basically, whatever we taught to you is there are two types. One is the classical thermodynamics, another is the statistical thermodynamics. Whatever we teach you, that is called as the classical thermodynamics. The difference between the classical and statistical thermodynamics is that classical thermodynamics, which is based upon the 4 law, that means one is the zeroth law, first law, second law, and third law. That means in classical thermodynamics, we treat the system as a macroscopic. Macroscopic means that we can see. But in case of statistical thermodynamics, we consider the system as a microscopic particle that we cannot see. That means atom, molecules, ions, such type, or electrons, such type, that we cannot see. That is the difference between the classical and statistical thermodynamics. So the classical thermodynamics based upon the 4 law. One is zeroth law, then first law, then second law, then the third law. Zeroth law thermodynamics deals with thermal thermal equilibrium and establishes the concept of temperature that we know that the temperature of the system we cannot measure directly. That is called the temperature. The zeroth law of thermodynamics deals with thermal equilibrium. That means whatever we taught you just before, ice converted to water, hot water converted to room temperature water, that is the called thermal equilibrium. Then at the concept of temperature, we know that the temperature of the system cannot be measured directly. So in that cases, the zeroth law deals with the thermal equilibrium and the temperature concept. Similarly, the first law of thermodynamics deals with the concept of internal energy. Internal energy means that is the energy stored in a system. That means suppose this hot water, this is the beaker, this contain suppose 40 ml of hot water. That means whatever be the energy stored inside it, that is called internal energy. Then second law sets the limit of converting heat into work. Limit converting heat into work. That means there is a certain limit that heat is converted into work. All heat cannot be converted into work. That was the limitation of the second law. And it also tells you the principle of increase of entropy. Entropy means the amount of disorderness in a system. amount of disorderliness in a system. Suppose that disorderliness means, suppose these are the atoms, these are in the order form. These are all are in the order form. That means this is only possible when the atoms are in the order form, means at only at 0 Kelvin. At 0 Kelvin this is possible. But when the temperature increases, these atoms starts to vibrate from its position. That means these atoms, suppose this is in the present in a system, so in another cases that means the atoms are vibrate and they are not in a order manner, they are moves here and there. This is called the increase of entropy. Entropy means amount of disorderliness in a system. And third law of thermodynamics deals with the absolute zero entropy. That means absolute zero means at 0 Kelvin all the atoms and molecules, the entropy tends towards zero. That is called the entire classical thermodynamics deals with this four law. Then deals with the four law. Then we have to know the certain thermodynamic concept. That's like system. System means the specified part of the universe which is under experimental investigation. That means suppose we consider a test tube. In the test tube we put sulfuric acid, then we put some zinc material, then the reaction takes place. So this inside the test tube it is a system, and whatever the present outside it, it is called surrounding, and the test tube surface that is the present outside is called the boundary. So system is the specified part of the universe. That means suppose this is my universe, then this is my system. Wherever we do some experiment and we get some results, and whatever outside present in the system, these are all are called as the surrounding. And the separation between the system and surrounding is called boundary. Then it is called boundary. Boundary may be three types. Boundary may be adiabatic. Adiabatic means the temperature, but the heat cannot flow, but it cannot conduct temperature, cannot conduct heat. Then or diathermic. Diathermic means it can conduct. Diathermic or adiabatic. Diathermic means it can conduct heat, and adiabatic means it cannot conduct heat. Then boundary may be real or imaginary. Boundary may be real boundary, just like our wall in a room. These are real boundary. It may be imaginary. We can imagine that we can imagine that this is my system and the boundary is here. So we can imagine. So boundary may be real, may be rigid, boundary may be imaginary, boundary may be adiabatic, boundary may be diathermic. Rigid, non-rigid also boundary. So we can tell that. So actually there are the four types of thermodynamic systems. The system and the entire system can be divided into four types. The system different types, four types of system. One is open system. Open system means suppose you consider, you take a beaker, then in the beaker what happens, now we put some, here is the sulfuric acid is there, we put some pieces of zinc, then the reaction takes place. In the reaction takes place when zinc reacts with sulfuric acid H2SO4, it converted to zinc sulfate plus hydrogen gas. This hydrogen gas is evolved and it moves away from the system, and zinc sulfate present in the beaker, and whatever the heat is generated, the heat also moves away from the system. So it is called as the open system. That means open system is the system which can exchange energy and matter with the surrounding. Similarly, closed system means the same. We take a beaker, then we put sulfuric acid, then we put some pieces of zinc, then zinc sulfate and hydrogen gas is evolved, but we put a lid over this beaker. Then what happens? And the hydrogen gas, whatever it cannot escape to the surrounding. So what happens? The zinc sulfate remain, the hydrogen gas is remain, but heat can moves away from the system. So closed system is a system which cannot exchange matter but exchange energy with the surrounding. Similarly, another is the adiabatic system. Adiabatic system is a system which neither exchange energy nor matter with the surrounding. That is called the adiabatic system. So in case of adiabatic system means adiabatic adiabatic system means which can neither as a matter nor as an instrument but exchange work with the surrounding. That means suppose 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 in our village there is a pond is there. Suppose sun's ray falls on it and water starts to evaporate. When the water starts to evaporate, they moves upward. When it moves upward, it undergo expansion and temperature decreases. It becomes cool. But when the water vapors are condensed to form water droplet or small ice is formed. When it comes back towards the earth, then it becomes contract and gets warmer. So this is called adiabatic system. Another is the insulated system. Insulated system is the system which can neither exchange energy nor matter with the surrounding. That means example is the thermoflux. In thermoflux, if you keep hot water or hot milk or hot tea, it remains as long as 5 or 6 hours. So it remains as hot. It is called insulated. It is called as the isolated system. So this is called the thermoflux. So difference between the adiabatic system and isolated system is that isolated system is the neither exchange energy nor matter with the surrounding, but adiabatic system also neither exchange energy nor matter with surrounding. But in adiabatic system, work can exchange with the surrounding. This is the difference between the isolated system and adiabatic system. So depending upon the phase and uniformity of composition, the system can be divided into two types. One is homogeneous system, another is heterogeneous system. Homogeneous system is the system in which what happens, it has one phase. And uniform composition throughout the system. But in case of heterogeneous system which contain more than one phase, but the number of uniformity of composition is different throughout the system. That means in case of homogeneous system, if you take example, one is the air. Air is a homogeneous system. Suppose in your room, any part of the room, wherever you take the air, it contains same amount of oxygen, nitrogen, carbon dioxide, whatever is there, the same everywhere is there. So air is a homogeneous mixture. Similarly, if another is the solution. Suppose you take a beaker, suppose you have the 20 ml of water and 2 gram of sodium chloride you add. So the solution is fun. Wherever you take the solution, same amount of salt, same amount of saltiness, you get a taste. So in that cases, we tell that these are the homogeneous system because it has uniform composition and phase is one. But in case of heterogeneous system, it contains more than one phase. What is the example? Suppose this is a beaker, 3 pieces of ice. Suppose this 3 pieces of ice is one phase. Suppose in that cases we put some water. In that case, what happens? Now the temperature of ice is not equal to the temperature of the water. The temperature of ice is 0 degree centigrade, but temperature of water is 10 degree centigrade. So temperature is different. So we tell that it is a heterogeneous system. Similarly, if you take this beaker and you put some water, then put some oil. In case of oil, there are two types of system. One is water and oil. So in that case of oil, there are two phase. So the physical chemical properties of oil is not same as that of the water. So it is a two phase. System. So it is a heterogeneous system because the physical chemical property of oil is not same as that of the water. So it is a two phase. So it is a heterogeneous system. Similarly, if you take a beaker, there is suppose it is the some part of food grain, then some sand you put, some sands. Here the physical chemical property of sand is not equal to that of the food grain. So it is also more than one phase. So it is also heterogeneous system. So based upon the phase and uniformity of composition, we can also divide the system into two types. One is homogeneous, another is the heterogeneous system. Similarly, we can tell that the property depending upon The thermodynamic property, there are two types of thermodynamic property. There are two types of thermodynamic property. One is intensive property, another is extensive property. There are two types of property, intensive property and extensive property. Intensive property means the intensive property means the property which does not depend upon the quantities of matter or size of the system, then we call that it is intensive property. It does not depend upon the quantity of matter, quantity does not depend on the quantity or size of the system. Example is temperature. Suppose in your room the temperature is at, suppose this is summer season, 35 degrees centigrade. Now you divide your room into four parts, imaginary, by giving imaginary boundary, and whatever the now the and your room is divided into four systems. All the four systems, that means suppose this is your room, the entire temperature of this room is 25 degrees centigrade. Now we divide this room into four imaginary parts, and these imaginary parts is the four systems, and wherever you measure the temperature same as 25 degree centigrade, so temperature is a intensive property. Similar also pressure. So pressure in your room is 1 atmosphere. If you divide by imaginary boundary into 4 or 6 or 7 parts in your room, then the pressure is same. So temperature and pressure is also a intensive property. Similar, temperature, pressure is intensive property. Similar also melting point and boiling point. Suppose you take the water you suppose 10 ml of water you take, the when you heat this water, it starts to boil. Suppose temperature is 100 degrees centigrade. So boiling, this is the called boiling point of water. When you take 100 ml of water, 100 ml of water, you starts to boil. Immediately at 100 degrees centigrade it starts to boil 100, but it may take some time. So 10 ml of water, if you boil, it may take 1 minute. 100 ml of water, you start to boil, suppose 10 minutes. If you take also 1 liter of water, it takes about 30 minutes. That depends upon the heat capacity. Heat capacity will differ, but boiling point will be 100 degrees centigrade, because when you put it thermometer in 10 ml water, you see that at 100 degrees centigrade, when it is, it starts to boil. Again, in 100 ml of water, you put a thermometer, you will see that at 100 degrees centigrade, it starts to boil. It may take some more time. But in case of 1 liter water or 200 liter water or 2000 liter of water, same is 100 degrees centigrade, it starts to boil. It may take different times. That depends upon the heat capacity. So boiling point is an intensive property. Similar also melting point is an intensive property, because it does not depend upon the quantities of matter. So specific heat, viscosity, surface tension, these are all are the density, these are all are the intensive property. Density means, suppose you take a glass of water, suppose it is 50 ml of water, you put 5 gram of sodium chloride, 5 gram of sodium chloride, then the saltiness is same. When you divide this 50 ml of water into two parts, each 25 is 25, same saltiness you get in the two test tubes. Whether you divide into four parts, the saltiness will not decrease, same saltiness. So density is the intensive property, but extensive property is the property which depends upon